in this question, the task was to find the vertex, the axis of symmetry and the y-intercept now. So just like the previous example, we know that this x square minus 6x plus 20, in this case the first task was this completion of squares. So this was x square. We just have to convert this 6x in the format of 2ab. So a 2 should be there, a is x, so we are left with a 3 now. So we have judged that the required b in this case for this formula completion is this number 3. So in order to complete this square, we should be having a 3 square here. So we should be adding a 3 square and we have to subtract a 3 square as well. So this is my required term just after the manipulation that we need. So we can see that now this is a perfect square. This is what? X minus 3 whole square minus 9. This is minus 9 plus 20, which makes it plus 11. So y is equal to x minus 3 whole square plus 11. This was the most important requirement that we had to handle. So in this case, can we now see that this is y minus 11 is equal to x minus 3 whole square, which means what? That the vertex of this parabola is the point 3 comma 11. The vertex of this parabola is the point 3 comma 11 and the axis of symmetry is simply the line x is equal to 3. So now in this question, now you have faced another part that we haven't discussed in the previous one, but it was very easy and it was expected that you would even hit upon this one. We had to find the y-intercept as well. So we know that, so this is the parabola. This is the required parabola. Its vertex was at the point 3 comma 11, which means x is 3 and y is 11. So we had to actually further find the y-intercept. So what does y-intercept means? We have heard this name earlier as well. Y-intercept means the point at which the curve is cutting the y-axis. So this was the y-intercept. So how do we find the y-intercept? We know that at the moment this curve would be cutting the y-axis, at that moment its x-coordinate would become 0. So just by looking at this equation, if someone has asked me the y-intercept, I can directly find that y-intercept by simply filling the value of x as 0. So if I just fill the value of x as 0 in the original equation only, we can see that y comes out to be 20. So this is the value of the y-intercept and this is the answer of that last part, which is the y-intercept. So right now we are dealing with the most basic structure in which the square completion is very straightforward and we are just dealing that simple upward parabola. Just an extension of the basic name, that is y is equal to x square. So let's solve one more and then we'll further take this story one step further. So just solve this one now. Another question based upon the same sense. So now we know how to do square completion. So this was x square plus 2 times of 2 multiplied by x. So in this case the required b was this number 2 only. So we had to add this 2 square and then subtract this 2 square and the 9 is still there. So just after writing this expression in this format, in order to complete this square, we know that this gives me x plus 2 whole square plus 9 minus 4, that is 5. So this was my required term. So this is actually y minus 5 is equal to x plus 2 whole square. So this means the vertex in this case is the point minus 2 comma 5. In this case, can we see that this was x plus 2, which means x minus minus 2. So the format that we know, in that format there should be a minus sign here, which was missing. So we have to create that minus sign over here. So in this case the right answer of the vertex would be minus 2 comma 5. So by chance if you have done this mistake, so it was very important for you to learn that the vertex in this case would be minus 2 comma 5. And after this the axis of symmetry would be the line x is equal to minus 2. It would be the axis of symmetry, it would be the line simple x is equal to minus 2. And if we have to find the y-intercept, we'll simply fill the value of x as 0 over here. So when we fill the value of x as 0, we get y as 9. So y-intercept, the value of y-intercept would be 9. this is the complete solution. And this sense also is actually very straightforward, but till this moment we have understood questions, we have dealt with terms which were in a way just the extension of the basic parabola y is equal to x square. We are till this moment we are simply dealing with the parabola in which the parabola is actually upwards, facing upwards, and we have dealt with a very basic structure just by moving that parabola, just by moving the vertex of that parabola, and we have created certain situations which was very important for us to learn. Now just understand this situation. Let's say instead of y is equal to x square, someone gives me a parabola which is, let's say, y is equal to some multiple of x square, let's say 2x square or 3x square or 1 by 2x square. So what does these multiple do actually to the equation of this parabola? If I simply multiply this by 2, then apparently on the graph, if I don't plot point by point, nothing changes much actually. Just imagine that if I fill the value of x as 1, the value of corresponding y would be 1. But if I fill the value of x as 1 in this one, the value of y would be 2. So can you see that in a way we have just stretched this graph. The height has just doubled. If I take this graph y is equal to 3x square, can we see that if I fill the value of x as 1 in this one, the value of y would be 3. So if this is the graph of y is equal to x square, then the graph of y is equal to 2x square would be exactly passing through this vertex, but it would be a bit higher than this one. It would be somewhat of this kind. But we don't have to fall into exactly the trap of, let's say, drawing this graph and whatever, and y is equal to 3x square would be further. It would be of this kind, because we can clearly see that this would be the graph of, let's say, y is equal to 3x square. And we can see that why it is happening, because in a way we are simply stretching this graph. But the important point is not exactly this. What we have to understand is actually a bit further than this point, but this is the basic sense if this x square is being multiplied with some number, let's say over here.